Linear dependence is an important concept of machine learning. It originates from the study of linear algebra, and it is also encountered in the study of differential calculus. In linear algebra, we mostly deal with vectors, whereas in differential calculus, we deal with functions of variables. In this discussion, the functions and the vectors, they are assumed to be equivalent, so the theory that is going to be discussed here will be equally applicable to the vectors and to the functions as well. Imagine someone gives you a couple of functions f1 and f2, and he tells you to find out whether these two functions are linearly dependent or not. How do you find it? So in order to find any given functions or any set of functions or the vectors, I would say, whether they are linearly dependent or not, we have a tool called Wronskian Matrix. So the Wronskian matrix can be constructed by the given functions in this way. The first row would correspond to all the given functions. So you're going to write down f1. Let me just shorten in this way, just keeping the variables implicit up to n functions. So these are the given functions someone gives to you and tells you whether these n functions are linearly dependent or not. So what you do, you write down a matrix. In the first row, you put all the functions, and in the second row, you take the first derivatives of the functions. So these are the first derivatives of the given functions. And in the third row, you take the second derivative of the functions. And in the last row, you take the nth derivative. Let me just scroll it up. So it should be nth derivative of the first function. It should be f1, fn2, f3, n, up to nth derivative of the nth function. If you take the determinant of this entire matrix and you, after the computation, if you find it 0, then it would mean the given functions are linearly dependent. And if you find it out that the given determinant of this Wronskian matrix is not equal to 0, then they are basically linearly independent. All right? So you have a tool, Wronskian matrix. Let's see an example. Imagine f1 is a function that is given by e to the power x, and f2 is a function given by e to the power 2x. Now, in order to find it, whether these two functions are linearly dependent or not, you just simply take the Wronskian matrix. So the first row would be the given functions, ex, and the e to the power 2x. And the second row would be the first derivative of these given functions. So the derivative of e to the power x is e to the power x. And the derivative of e to the power 2x is 2 times e to the power 2x. And if you take the determinant of this Wronskian matrix, you just simply cross multiply them and you're gonna get e to the power 2x times e to the power x, e to the power 2x times e to the power x. So that gives us 2 e to the power 3x minus e to the power 3x is equal to e to the power 3x. So it is not equal to 0. That means the given functions f1 and f2 are linearly independent. All right? They are linearly independent. Now, if I give another simple example, let's say this time if 1x is equal to, very simple example, sine x, and if 2 is equal to cos x. What do you think? Are they linearly dependent or independent? Well, let's check. Let's write down the Wronskian matrix. The first row would be the given functions, sine x, cos x. And the second row would be the first derivative of the sine x, which is basically cos x. And the derivative of the cos x is negative of sine x. And if I further simplify it by taking the determinant of this matrix, then I will, this is negative sine square x minus cos square x. So it turns out to be sine square x plus cos square x is equal to minus of 1, which is not equal to 0. So the given two functions f1 and f2 are basically linearly independent, all right? So this feature of linearly dependent or independent is very important in machine learning, especially in convolutional neural network. During the training of the data set, sometimes it shows some overfitting, and in order to reduce that noise in the data, you can just discard the linearly dependent features of the data set and can clean up the data a little bit more. Hopefully this video was very helpful to develop the concept. Thanks for watching.